Welcome back, children. Today we will study suspension. Now, what is a suspension? A suspension is a heterogeneous mixture in which the particles remain suspended throughout the entire mass of the mixture. Clear? So, if we go through the properties of suspension, it will become more easy for you to understand. So, let us go through the properties. First property, a suspension is a heterogeneous mixture, means you can easily identify the particles by your naked eye. It will remain suspended throughout the entire mass of the suspension. Second, the particles of a suspension are visible to the naked eye. Naturally, I told you, you can see them even with your naked eye. Not even a microscope is required. Third, it is unstable. Now, this is very important. If a suspension is kept undisturbed for some time, you will find that all those particles which are visible to your naked eye, they get settled at the bottom of the container. That means it is not stable like solution, rather it is unstable. Fourth point, the particles in a suspension can be separated by filtration. Again, this is opposite to that of solution. In a suspension, the particle size are so big that it can be easily separated from the suspension by the simple method of filtration. Means these particles which are visible to your naked eye, they will remain in the filter paper as the residue, right? And lastly, the size of the particles of a suspension is 10 to the power minus 5 centimeter or even larger. That means the size of the particles are very, very big. That is why you can see them with your unaided eye, means without the use of microscope. Just by your naked eyes you can easily see them, right? For example of suspension is when you make a mixture of chalk, dust and water, then you will find that the chalk particles, they remain suspended throughout the entire mass of water. So this is an example of suspension. Similarly, muddy water, that is also a suspension. Mud particles remain suspended in water. Muddy water is also an example of suspension. Well, children, the next one is colloidal solution. Now, what is a colloidal solution? A colloidal solution is a heterogeneous mixture whose properties are intermediate between that of true solution and suspension, right? Examples of colloidal solution is milk. Remember, milk is a colloidal solution. The blood is also colloidal solution. Ink is also colloidal solution. So let us go through the properties of colloidal solution. First, a colloidal solution is heterogeneous. Naturally, you can see the particles with a microscope, right? Very rarely you will be able to see with your naked eye, but definitely with a microscope you will be able to see the colloidal particles. The particles in a colloid can pass through a filter paper. So this is also similar to that of solution. They are so small that it can easily pass through the pores present in a filter paper. Clear? So colloidal particles cannot remain as residue if it is filtered, like that of suspension. A colloid is quite stable. Means if you keep a colloidal solution undisturbed for some time, it is not that the particles will settle down at the bottom. It will never happen. Just like the case of true solution. So in that case, a colloidal solution is stable in nature. Next, the size of colloidal particles ranges from 10 to the power minus 7 to 10 to the power minus 5 centimeter. See, this is intermediate. In case of suspension, we have seen the size of the particles is 10 to the power minus 5 centimeter or larger. And here the colloidal particles have a limit. Smallest is 10 to the minus 7, largest is 10 to the minus 5 centimeters. Right? Particles of colloidal solution show Brownian movement. Now, what is this Brownian movement? Now, it is found that colloidal particles move in a random zigzag manner. This happens because of collision between the colloidal particles. Such type of spontaneous movement of the particles throughout the colloidal solution is called as Brownian movement. Next is colloids show Tyndall effect. Now, what is this Tyndall effect? When light, supposing a beam of torchlight, is allowed to pass through a colloidal solution, then inside the solution that whole path of light will be visible. This is called as Tyndall effect. Just like you must have seen that in a dark room in the early morning when sun rises, through a small hole in the ventilator, a narrow beam of sunlight enters whose path can be seen easily. The path becomes visible in that dark room. So this is an example of Tyndall effect. Similar type of observation is also found when in a forest from the canopy of trees, as beams of sunlight enters through various gaps, that path of sunlight can be seen easily below the large trees where almost little darkness prevails. So this is also Tyndall effect. And lastly, colloids show electrophoresis. Now, what is this electrophoresis? Well, many colloidal particles have charge in them. So the movement of colloidal particles under the influence of an electric field is called electrophoresis. So when an electric field is applied, then the colloidal particles show movement either towards the positive or towards the negative electrode. So this movement of charged colloidal particles under the influence of electric field is called as electrophoresis. Right, children? So this is all about suspension and colloidal solution. Here, till now, whatever we have done is almost the end of half of the chapter. Next, we will do regarding the separation of substances, right? So that we will do in our next class. Thank you for today.